Okay, hello students. Today in chemistry we discuss the particle nature of radiation. We already discussed the wave nature of radiation. Now today we discuss the particle nature of radiation, electromagnetic radiation. So this particle nature of electromagnetic radiation, its theory first is given in 1900 by Max Planck. Okay, that is known as Max Planck quantum theory. Quanta means the amount of energy. Then we discuss about black body radiation. And third topic related with is photoelectric effect. First we discuss the Planck postulate. The scientist Planck postulate is covering the three topics. One by one we discuss these three topics. This theory is again modified by scientist Einstein. So that we will discuss one by one. First, radiation emitted or absorbed by the form of small packs, that is known as quanta. So whatever light emit or absorb, that is in the form of quanta, means package, and that package is known as quantum. Okay? If it is light radiation, then another word that is known as photons. So photons of light emitted or photons of light absorbed. Second, the energy of radiation is directly proportional to the frequency. Energy E is directly proportional to the frequency mu. Therefore, E is equal to h mu, where h is a Planck constant. We know that frequency mu is equal to c by lambda. Therefore, E is equal to sc by lambda, where h is a Planck constant. Its value is 6.626 multiplied by 10 raised to minus 34 joule second. Okay, 10 raised to minus 34 joule second. Third one, the total energy. In chemistry, we find the energy for 1 mole. So energy for 1 mole of photon electron, that is 1 Einstein. So you multiply by number n. E is equal to n sc by lambda, or E is equal to n0 sc by lambda, where n0 or n is nothing but it is equal to 1 mole of electron, 1 mole of atom onwards. So 1 mole or 6.022 into 10 raised to 23 molecules or electrons, that is equal to what? 1 Einstein. So again I revise last topic, that is 1 Einstein is the energy absorbed or evolved by 1 mole of photon or 1 mole of electron, that is known as 1 Einstein. Okay. Second we discussed, that is of black body radiation. Black body radiation. Okay. Black body radiation or black body. Particular body, it absorb radiation and emit radiation. If particular body absorb blue color, then it emits green color. So absorption and emission is going on. It directly proportional to its wavelength of light absorbed. Suppose the particular body absorb light of all wavelength, all color absorbed, then that body is known as black body. So we discuss about black body, the phenomenon of black body radiation. Before going to this black body, we try to understand the color when iron metal is heated. On heating a solid, its atom starts oscillation. First oscillation of atom will start. So whenever when you give energy, heat energy, atom or particle or electron starts to vibrate, oscillate, and this oscillation then further produce sound, magnetic field and electric field, okay, or light field. So it emits radiation. So emit radiation. When heat is given to the solid, it emits radiation because of vibration or oscillation. As for example, iron rod, if it is heated, first it turns to red color. This red color, again you give the more temperature, then this red color turns to white color. That white color, again temperature is increases and it turns to blue color. So if the temperature is increases, the wavelength absorbed by this iron rod, it is decreases. Hence its energy is increased. We know the energy and wavelength equation. E is equal to Sc by lambda. So lambda and energy. Okay? Lambda means wavelength and energy is inversely proportional. Wavelength decreases, energy increases. Remember. A body which absorbs or emits radiation of all frequency is known as black body. Radiation emitted by the black body is called black body radiation. If you study the graph of temperature against wavelength, then here I have drawn the graph of intensity. Intensity means the energy. Energy and wavelength. So here rod is heated, its absorption peaks or emission peaks is at 2500 nanometer. Wavelength we measure in nanometer. That is T1 temperature. If the temperature is increases T2, then its radiation is around 1200 nanometer. So wavelength decreases. So temperature increases, wavelength decreases. But you can see the intensity, this graph is increases. Means energy is increases. So from this black body radiation, you kept in the mind the temperature increases, wavelength decreases, and energy is increases. Okay, fix it. Again, temperature increases, wavelength decreases, and energy or intensity is increases. Third topic, that is about photoelectric effect. We discussed photoelectric effect. Okay, third point we discussed, that is photoelectric effect. Photoelectric effect is given by scientist Hertz in 1887. Photoelectric effect means when light falls on the metal, it's emit radiation. First one, if light falls on the metal, the electron in the metal starts to oscillate. This oscillation starts, vibrations and oscillation starts. When it's reached to particular height or particular frequency, emission of electron will take place. This is known as photoelectric effect. The minimum amount of energy which is required for electron to eject out, that energy is known as threshold energy, and frequency is known as threshold frequency. Today we will discuss about photoelectric effect. Here you can see photoelectric effect is there. Here tube is there. In this tube, this metal, polished metal is kept. Light energy is fall on it. Okay, of particular light in the form of energy, light fall on it, and metal starts to vibrate it. Electron are ejected out, and it is detected by this detector. It is joined with the emitter. Or emitter is there, here battery is there, so it will detect the signal of particular energy. We discuss the photoelectric effect, the phenomena for ejection of electron from suitable surface of metal having suitable frequency. That is known as photoelectric effect. Electron ejected are counted by the detector. So this detector is there. That is measure the result of its kinetic energy. This kinetic energy, that is known as half mv square. Okay. Kinetic energy means speed and rotational energy means the round. The result of this photoelectric effect, electron emits when light fall on the metal. So first observation is electrons are emitted from the metal when light of high radiation falls on the metal. The electron eject is directly proportional to the intensity of light or energy of the light. So amount of energy of electron which is emitted out is directly proportional to the amount of absorption. Second and third, minimum energy required for the emission of electron is known as threshold energy or threshold frequency. Electrons are revolving around the atom. When light fall on it, this electron, then it starts to rotate fast. Again, when proper frequency of light is emitted, this rotation will be very fast, and again when this rotation reach to particular level, an electron will bounce back and come out from the atom. That is nothing but the emission radiation for this electron. So minimum amount of that energy, that is known as threshold energy, and frequency related to that, that is known as threshold frequency. Now we know that E is equal to h mu, which is equal to E is equal to Sc by lambda. If this h mu is the energy we give to the metal, then two type of energy will be there. First one is this threshold, means minimum energy is absorbed by the system, and second is the kinetic energy of electron, which is ejected out. So first one, h mu 0. Mu 0 is nothing but potential energy or binding energy. Binding energy means the energy of the electron which is pulled by the nucleus or proton in the center, which not allow electron to go out of the atom. So that is binding energy. If you overcome this binding energy, more energy, then remaining energy where the electron which is migrated in, that is the kinetic energy. So if you find the difference, h mu minus h mu 0, which is equal to half mv square. So from that we can find the energy. Mu or h is the constant, then mu minus mu 0 into h, which is equal to half mv square. H is the Planck constant. So different in the frequency. From the different in the frequency, we can calculate the kinetic energy of the light emitted or the electron of the kinetic energy of which is ejected up. So this is all about photoelectric effect. Okay, you write the notes in your notebook and try to solve the sums of textbook. Thank you.